Makes it so much easier to tell what I do if I just show a bunch of our customer work. But thank you very much for coming today. I'm Paul Cousens. I look after the clean technology industry for Autodesk. And like everyone in the room here, we all share the same goal. We're all trying to help promising clean technology to get to market faster. Whether you're in the investment community in the room or the 26 startup companies that are here, it's a challenge. We know that. And at Autodesk, we recognize that most of the innovation in clean technology was happening at the early stage company level. However, early stage companies don't typically have a lot of money. So we started a program called the Autodesk Cleantech Partner Programme where we can invest up to $150,000 of our, or 150,000 euros of our software into any promising clean technology company. But the real thing we want to do is help those companies design better products. So today I want to talk a little bit about how design technology can drive innovation in clean technology. And I'll start with one of the best examples of design, the automotive industry. So we heard the mobility panel this morning, and certainly we're talking about the importance of driving people to your product you're making. But there really isn't an industry more reliant on design than the car industry. You know, if you're an industrial designer, it's the top of the food chain to get a job working at Mercedes or Porsche or Ford or designing new cars. But the reality is everything in the built world needs to be redesigned. From the smallest microchip to the biggest city. In the past, things were built without sustainability in mind in many cases, or just form or function. So as we look at the changes that are happening in the whole clean technology industry, automotive is certainly a good example. And back to why design is important, it's often said that your house is who you are, but your car is who you want to be. And that's kind of why a 40-year-old guy with a new convertible that lives in his mom's basement is actually not that cool. You know, but so much innovation is going into designing new cars, and you know, the same need is there for clean technology. It doesn't matter what you're making, a water purification device, an electric vehicle, any kind of air monitoring system. It needs to be redesigned. And so as a leader in 3D design technology, whether it's an architect or an engineer or an animator, we want to make sure those powerful tools are available to people to make a better product, to get it to market faster, and to know how it's going to perform, to simulate the heck out of the thing so you know what it's going to do. And again, to sell that idea. So for the investment community, quite often, you get a presenter up on a stage like this who's probably an amazing designer, an amazing entrepreneur to have 3 PhDs to figure out how to do something, but he can't sell his idea. You know, he's got a puppet show or an Excel spreadsheet to explain why he's better. Often we use our visualization from our background, and my background actually in visual effects, to put that into our engineering software to help you build animations. Like our Velocopter gentleman, he had an animation to show how that worked. You all understood what his product did. Building information models. Every building in the world is designed by architects using our software. Buildings like this, and they know, certainly, I'm sure this building's fairly new, and they would have tried to make some design choices to make it breathe better and to make it cheaper to run, and obviously the lighting in here for that. So these are all different technologies that come together, and when you have more information, like a building information model, like in this is actually our office in Boston, you can make a better decision. So sometimes it's even just the daylighting. So when you get a visual thing, so at winter and summer solstice are coming up, the light goes in differently. And so if you just render that out really easily in a software, you can make a better decision. You know where to be putting things. So just a quick example of where that is. To me, the real reaching goal is sustainable clean tech design. So here's a good example of the California Academy of Sciences, designed by nice architect Lorenzo Piano. But it's a LEED Platinum certified building. It's a beautiful design, all these kinds of things. That's what we're all reaching for. Because it's one thing to make a clean technology product, but to not design it sustainably, it really should be. And so we have a lot of tools in our software that can help people make a better decision to help get their product to market faster. And people are finding the market wants products that behave like that. Bring it all together, more sustainable cities, urban planning, all these things. So any new cities that are being built, they're using a lot of our software to make better decisions than they did in the past. And I run a sales team, so I try to know as much as I can about selling different products, but it's really you need to differentiate your product somehow. In order to unseat an incumbent in any market for anything you're selling, you basically have to be 3 times better than the other person, and you got to make that clear. And so the design is a big key piece of that. People need to know it feels good in my hand, or I can see that works there, or back to the car industry, that's a cool looking car. I want to be seen driving that. So again, with the Cleantech Partner Program, we started this a couple years ago. We've got a couple thousand companies in the program now where we've invested our software, to help them get to market faster. So again, we do encourage you to come see Tanya and I after the next break. And for part of our investment in the conference here was to make sure everyone had 11,000 euros worth of software to help them do all these wonderful things. So a few examples of some companies in our program, and actually a few of them are even here. So NTS is going to be presenting later, but there's a really neat technology. We weren't thinking of doing these things as a community 20 years ago. And you know, to just harness the power of the wind and simulate your product and know how it's going to perform, to make your best prototype digitally, make all your mistakes in pixels instead of atoms, you're going to get a product to market faster like NTS has. You know, other two good examples, right? So Ecoduna and Enbreeze are both here as well. You know, we liked them so much, we did a success story in them to help other people do that. So they use our technology really well, and they wouldn't have got their products to the stage of the market if they'd done things differently. So we're really proud of that, and we judge our success on how our partners are working. But a good example on the visualization, there's one of these is a photograph, and one of them is a digital rendering. Can you tell it apart? Probably not. You know, so one's a photograph, one's a rendering. That's great. This one cost $2.5 million to produce. $75,000. It wasn't a clean technology. It's a cleaning technology. It's actually a street cleaner. But you know, it's much cheaper to design digitally, as you can prove. And the time, that's the big thing, is all these products need to get to market faster. So if you're going to take so long to build all these physical prototypes, that's expensive. They're difficult to ship around. And what if you build an 80 kilowatt machine when the market wants a 90 kilowatt machine? You're stuck with it. If you've done that all digitally, you get the orders for the 90 kilowatt, you know how it's going to perform because you've designed and simulated, then go to tooling and get that done. So the whole idea of digital prototyping is kind of keeping an idea of a product moving from ideation through engineering, through simulation, through visualization. So if you're designing in 3D, you can start marketing before your product's manufactured. So just your first ideas, you can have 5 or 6 different, I think that, here's what the market might want, go to market, test it out, get an order, get some interest from a venture capitalist, and go and build that product. So it's a big way we're using all of our technology to support the industry. But it's really about driving innovation. And that's, again, what we have in common in this room. We're all trying to innovate new business models, new products, new ways to get a product to market, to unseat maybe a dirty tech incumbent or other kinds of things. But innovation is key to that because it's about change. It's about doing things differently. And I want to talk about 4 trends that we see at Autodesk that are happening in this market and where you might be able to take advantage of what's going on. At my job, my nickname at work is the Green Santa Claus. I donate software to all the good companies and stuff like that. I get to see a lot of cool companies and what they do, but I get to see the ones that are finding success and things they're taking advantage of. The big thing is business unusual. Things are changing, from the power of the cloud or the power of the crowd for crowdfunding, going to different investment vehicles. And we had years ago, people will go into Kickstarter and throw 20 bucks in, and eventually a guy can have enough money to start things up. This is an example. It's not a clean technology, but it's still an important technology that is important to get to market. For years, the scientific community struggled with sequencing some genes inside the HIV virus. And it was a puzzle for them. They couldn't figure out how this must connect there, and they weren't sure. A big, smart group of guys at MIT were working on that. So what they did is they made a 3D model using Autodesk software and put it out on a website called Foldit, a puzzle site where people who are pretty good at putting puzzles together said, here's our problem. We can't figure out how A equals B, and we know a bunch of rules. In 2 weeks, someone solved it for them because we're able to use the power of the crowd. And that, great, the researchers there wouldn't have figured that out if it wasn't the power of the whole community, the open source. So this is happening in design, and more people are open to sharing their designs, not their unique intellectual property, but the ability to collaborate and get other people to help is a trend that's fairly new, and it's something we can all be taking advantage of. And breaking the mold too, we talk a lot about Tesla at Autodesk. They're a big customer of ours, and I think a great example of a new clean technology where great design and great engineering and a unique business model. Like, look out Detroit, look out Stuttgart. There's guys building cars in California again. That doesn't happen all the time. I think this is probably the most disruptive change that's going to happen in the market for all of us is the digital fabrication. So, the whole idea of the supply chain of only being able to manufacture a product in one area and then ship it all around the world is going away. As rapid prototyping comes on, it used to be about $1 million to get a system that can do a rapid prototype of something. So it was pretty expensive for each iteration you were making your product. The market has really come together. You now can get a really good for maybe $50,000, 1,000 euros, and kind of some basic ones for around 10,000. It's really driving down the ability to make your products on site. You don't have to wait, you don't have to ship, you don't have to have one guy with a tool and die shop in one place to ship it over there. And this is really going to change how products are made. And again, distributed, which is a very big business in the world that may just even go away for a lot of things once we can be like Star Trek and just hit the button and the product reduces. So there's additive kinds of, so, building, plastic models and, adding products to build up something. There's subtractive, like a lathe, where you're going to take away, the robotic assembly. And even now in the nanoscale, are different kinds of digital fabrication that are happening. And so look at that for your company or the companies you're investing in is, are they doing that, or could they, or should they, or when's the price finally going to fall enough that you don't have to have someone else make it for you? You can make it on site. So now Nike, big customer of ours, they make prototypes of their shoes digitally. They print them in digital printers. That's a shoe that they printed out to get the size and shape, and they don't have to build a whole last and the rest of the shoe to put it together. So they can do that in plastic. They can do that in what you're going to be wearing tomorrow, I think, Jan. You can put your outfit together. You could even do it in metal. So you can fabricate it in metal. So all these things are new technologies you couldn't do before that we could take over. So there's another car company. This is from Winnipeg, Canada, my home country. So they did a full fabrication of a car with a digital print. It's the first time anyone ever did that. And so they're trying to get a 100-mile-per-gallon engine vehicle to market, but they don't have to rely on the old way of making cars. They're trying to be innovative and break the mold. And I think it's a good example of what we can all be thinking about for our companies of doing things a bit different. The infinite computing, often referred to the cloud, it used to be that the big cost was the computer. So last year's people at the Ecosummit, they had this kind of technology, I understand, to get going. But that's so far gone now that, the power in just, your mobile phone is more than was in the very first space shuttle that went up there. But I want to make another point. See anything wrong with this picture here? Look how old that phone is. That's like an iPhone 1. You kidding me? So if anyone noticed that that's not the iPhone 5, you just sold yourself on design matters. We're all aware of what old technology looks like and what new technology looks like. So as you're designing your products, use design best practices. Use the best things, because even that picture, again, that's an old technology, but we're still making the same point is there's a lot more in that than there was in the space shuttle. So know that how those things change. And basically the price of a computer now is negligible. It's almost free. Back in the day, you spend $50,000 to buy some SGI or Sun computer to do some high compute. You don't need that anymore. You send it out to the cloud, as we know. Instead of, doing one simulation on your computer and waiting for it to run, you can send it out to 1,000 computers, and it'll get you the answer back. Our customers find a lot of this, especially in the simulation industry. So computational fluid dynamics, really big compute, really a lot of information that's really important. You need to know how your product's going to perform. So some architect or designer would have designed the ceiling tiles up there to make sure they know how they perform and, they're not going to fall and that kind of stuff. But sadly, they were probably installed by the lowest bidder. But yeah, you need to simulate products to know how they're going to work, and it's a big important. So all of our cloud technology is driving a lot of our simulation software has really been moved over to the cloud at Autodesk. So for people in our program, we can get you access to great cloud technology so you can do mass simulations that you couldn't even a short while ago. Wrapping up for the prototyping for the future, again, the whole idea of an entire design that you're going to do. So, put your whole system together so you can collaborate, use the same tools that, maybe your industrial designer's outside of the house, but he's using the same tools as you, and moving your whole workflow from ideation through engineering, through simulation to sales and marketing, in storing it all in a centralized data. It's stuff that you couldn't do easily or you couldn't do without a big capital investment in the past. This is all available. This is all available in the software we're investing in the teams here. So, the other things is, so for, again, building digital prototypes, there's a Green Ocean Energy, a customer of ours in the UK, that's a 300-ton machine. You can't build that twice. You build it once. So they did all their simulation, all their visualization, all their engineering digitally, so they knew how it would perform before they sold it. And so, again, wrapping up with one last one, being here, for as you get more systems together, more communities and things. So, Project Vasari is one of our big integrations of simulation, in a civil environment. So all these things are changing, but making visual decisions is important. So I really hope we can get to know you here at the show. We're thrilled to be a sponsor of this event. This is exactly the community that we all serve in our role at Autodesk, trying to be a leader in the community of investing back. If you need any of our tools, we'd happy to get you started. Or if you're an investor in the community and you want to sleep better at night knowing that your team has all the right tools, if they're designing clean technology, we're happy to invest in them. If they're doing dirty technology, they're on their own. Thank you.
Great. Does anybody have a question for Mr. Autodesk from Canada, also known as Paul?
Paul, how far away do you think is laser sintering, additive e-manufacturing from mass market penetration?
I would be difficult to pick a date, but it's moving quick. Like if you look any of the curves on what I'd say the cost was for those machines, I mean because people in that industry, they see the growth. Like they've got hyper growth they can do. So similar to clean technology, as some new mousetrap, someone's going to come up with a slightly better technology or a new way of doing it that's going to drive the cost down for mass market. So different. A lot of the plastic stuff and rubbers, they're pretty good right now. I think you said metals, that's a higher level in the food chain. So I wouldn't want to guess on a date, but I bet you every day it's getting faster. So I couldn't pick a date, but count on it happening and count on it really being disruptive is what I'd like to say.